This shows the inputs for the ninth embodiment of the power supply of the wireless bipolar Tesla coil. We're looking at these secondary arrangements, see if we can improve them or not. And we're going to go over the ordering of the placement of inductors on that system. There's the system as color-coded by phase. One will notice that the phases circle around each other, similar to a barber pole. And once the reactance is found for that situation, the system is tuned for that situation. We have 6 poles in mutual inductance in between each color change. Okay, that's known as a 666 primary system. Now we also have inductors upon that system. We combine these inductors in series. Each of them inductors are respectively 2.6 Henry for the front one, 2.7 Henry for the back one, and each are given 50 nanofarads approximate capacity to resonate as single loops. The outside wiring connections of each coil are connected and made common. The inside coil connections of each wiring yield the voltages respectively. So here in this example, even though we only have a 1 volt input with no field turned on, we've got a pretty meager amperage levels on each of them phases. We got 0.1, 0.3 around in there fluctuating on phase 1, 0.08 on phase 2, and 0.18 on phase 3. That's with those inductors placed as we see them. And as we see those inductors, we will place them on our checkerboard scheme to show what we're going to do. The green one's the starting coil in the phase rotation. That's the 2.6 Henry coil. Black one's the ending coil in the phase rotation. We're currently right there. What we're going to do is we're going to move the black one back, look at the results. Then we're going to move the green one up, look at those results. And then we're going to move the black one over to phase 1 and look at those results. Those results will be opposite coil formations of the result we initially obtained, which was this. Now to quickly look at the voltage rises on the system. Again, I say we have, wonder how this thing can power a Tesla coil. Well, it's about a 300 to 1 voltage rise on the circuits. 1 volt input across the board. Got a little glare there. On the back coil, we have 29.4 milliamps producing 147 volts. On the front looking coil, we got 27 milliamps producing 183 volts. And the common lines being connected on the outside windings, identical coils, we have 302 volts across the inner windings of both coils, and we use that as the power source for our Tesla coil, air core Tesla coil, wireless, no ferromagnetic transformer. This replaces the purpose of that ferromagnetic transformer. Now, before we give a load to this process, we're going to look at the phenomenal efficiency involved here on phase 1. We've got about 1/10 of an amp. That amperage is reduced 5-fold down to about 27 milliamps. But instead of rising 5-fold or 6-fold to 5 or 6 volts, it rises to 183 volts. That's the good performing phase. The other phase has got about 0.08 amps on it. Let's look at that again. Phase number 2 has 0.08 amps on it. And at 0.08 amps, or 80 milliamps, is reduced to 30 milliamps, but yet it has 146 volts across it. So the generated voltage is way higher than what the turns ratio predicts in ordinary ferromagnetic transformer theory. Now let's go play our shell game. Starting from here, we've got the green and the black. We're going to move the black one so it's covering phase 3. We'll go over there and move the coils. And we'll do a background to that so we can see our new generated voltages. I'll come now. Damped in here. Whoa. Pardon me, folks. Situation's a little cramped. We're going to move that back. Now I have the new circumstance. Only 195 volts being produced between the pair. 2/3 is effective. 30 milliamps on that coil we moved. 18 milliamps on the other coil. We're going to move it one more time. We're going to move the green coil now. Starting coil on our checkerboard scheme. We're going to move that one back one. Back to our inputs. And as we can see, that might be a little better than the first time. We got 308 volts between 149 and 182. We've got 30 milliamps in the front 2.7 Henry coil, and we got 27 milliamps on the back 2.7 Henry coil. Now we're going to make the final adjustment. We're going to bring that front coil over one phase so that now we're backwards from where we started. And when we're backwards from where we started, that's what that looks like on the checkerboard scheme. And here we go. as we can see, we got totally different results depending upon how we sequence these coils. So we'll leave that to the readers or the viewers of this video for a mystery, and let them explain to themselves how such a thing can be. Now when I first seen this, I said, oh, this whole thing makes me want to cry. It makes no sense. But there are things in here that will tell you why it makes sense. So we decide then we would probably want to use this system over here. Power our Tesla coil, since it gives us the best results. Thank you.